So could we divide by 2 on both sides?
Yep.
Gives you 8a squared equals root a.
Can you hear me? Hello? Ah, there you go. Can you hear me?
We got to work in. Yeah.
Alright. So, any idea what's next?
That you could have a way root both sides.
It's already
Square
rooted.
both sides, sorry.
Alright, square both sides. What do you get?
8a cubed equals a.
Very wrong. So right side is a. So you want 8a squared squared.
Oh, yeah. Let's multiply. Let's multiply. It's 4. When you're multiplying, it's adding, right? It's 4. Yeah.
And it's not 8. Everything is
And
squared.
it's
Say it again, sorry?
64.
Yeah, sorry, the keeps cutting out.
Yeah. And then you can divide by a on both sides.
You'll lose a solution if you do that. What you can do is just bring them over, like make it equal to 0.
Okay. And then you could divide by 6. No.
Stop at your factorize.
We factorize out a.
Yep.
So you get a, and then a to the a cubed minus 1. 64a cubed minus 1.
Yep. And solve.
Wait, could we plus 1 on both sides?
So either a is 0 or second one is 0. So it's like GCSE quadratic stuff.
So you just sub in a for 0. Either.
So either that one, so the two things multiply to make 0. So either this first one equals 0 or the second one equals 0. Something
So
telling me.
that's either 0 or minus 1.
Now,
Minus 1a.
now,
Minus a.
so solve this. Just solve it like a normal.
Oh, so you can solve it as a cubic.
Yeah.
And you get a quarter.
A is equal to a quarter. All right. Okay, how about B?
Could you just solve it as a... Or do you're not allowed to use a calculator at the start?
Yeah, it says use an algebra.
Okay. So would you want to plus 18 on both sides first?
The trick here is let b squared be equal to u. What do you get?
So it'd be 2u. Oh no, u squared, right?
Yeah.
Equals 7u minus 18 equals it. And then you can solve that into quadratic.
Yeah. But using algebra, maybe factorize it.
So you factorize out u.
So, GCSE style.
So it'd be U plus 7.
No, how have you forgotten this? They multiply to make 18, minus 18, add to make 7. Two numbers.
One of them will be negative, one of them will be positive, so.
Yeah. Two numbers multiply to make 18.
There's 1 and 18.
Mm-hmm.
3 and 6. And then there's 2 and 9. So minus 9 add 2.
Let's see.
So one of them's minus 9, one of them says
We need
2
to make plus 7.
Yeah, so oh wait, no, minus 2 at 9.
Yeah. So that's minus 2 and plus 9. And so what are the solutions?
U equals minus 9, U equals plus 2.
So u equals minus 9 or u equals 2. However, we don't want u, we want b.
Yeah.
What is u the same as?
B squared.
So b squared is equal to minus 9 or b squared is equal to 2. Solve. We want b.
So it would be minus 3. That's impossible to get minus 9.
So that one's, there's no solutions for that one.
Yeah.
No real roots. How about the other one?
What do we root 2?
Yep. Is there another very similar number that when you square it, you also get 2?
Negative root 2.
Yeah. Plus or minus root 2. Okay. Tricky. Let's see. First one, you have to square both sides to get rid of the square root.
Yeah.
Or you could let it be equal to, let root a be equal to u. You could have done it that way.
Yeah.
For the second one, b squared, so it's like a quartic, and we have to use algebra. And so let the smaller one, the second term, b squared be equal to u. Solve it as a quadratic, and then just swap it back and solve that. Hey, it's common enough. Would have worked for both. Okay. How about this?
So we just find that you just do integration for the first one.
How do you do it?
Could we make it so it's 4? Could we convert 4 over x cubed to 4x to the minus cube?
Mm-hmm.
And then we multiply by the coefficient. Let's divide by the coefficient, then add 1.
Add 1 first. Divide by new power.
So it'd be minus 2x to the minus 2.
I believe so, yeah.
Plus c.
Slow down. So that's kx.
Okay.
K is just a number. K is a constant.
So it'd be like a half kx to the 2.
Yep. And that is plus c. It says simplifying your answer. Any idea what that's about?
No.
I think in the same way that we changed this to like to the power of a minus, we should change it back to the way the question is.
Oh, so it can become like minus 2x over 2.
Minus 2 over x squared.
Okay.
Everything else is fine, I think. Alright, part B.
So for this, we've got the answer already. You just need to sub in 2 for x, and then minus it from subbing in 0.5 for x.
Yeah, but we're trying to solve for k. So we sub in 2 for x. So wherever there's an x, we replace it with 2. So c minus c is going to be 0.
Yeah.
So I'm not going to bother with that. Then we have this other one, 0.5 squared. And we're told that that whole thing is equal to 8.
Yeah.
Alright, what's next?
We can simplify.
Alright, what do you get?
So on the left you get minus a half,
Okay,
and then if you simplify k, it would be like 4 times a half, so it'd be 2k.
that's good.
And that'd be minus, and then minus 8. And then 18k. E plus 8.
Right.
Just simplify even further now.
Yeah.
So does the minus and 8 make it positive?
So what would you get?
Would it be like minus a half plus 8? Which gives you 15 over 2.
Okay.
And 2k plus 1/8k.
So that's what I was waiting to see. The way you subtract, so it's like minus this whole thing. So that's the same as expanding it by minus 1. So if you expand that bracket by minus 1, you get plus 8, but you get minus an 8th k.
Ah, okay.
So 2k minus an 8th k. It's like 15 over 8k, something like that.
15 over 8k, yeah.
The whole thing is equal to 8.
And then you can minus 15 over 2 on both sides.
Yeah. Is it a half?
Yeah.
Okay.
Multiply by 8 on both sides.
Yeah. You get 4.
And then divide by minus 15.
Yeah. K is 4 over minus 15. That's great. Okay, so it took a long time, but I knew you'd get most of it right. I couldn't skip the minus part. The part
Yeah.
everyone gets wrong. So it's very common with integration that is like, one thing minus another, but the second part has like a bracket. There's multiple parts going on. So anytime you have to subtract a bracket or subtract lots of things, just expand it by -1.
Yeah.
And then just go about the rest the normal way. Other than that, you're good. All right. These questions used to be weird. Now they're coming up all the time. All right.
So it'd be equal to h, right? The equation.
Yeah.
Then however many years it passes, it's like plus however many t. So
Right.
if we do 3.28 minus 2. Would we need to do 2.35 divided by 3
To
get like the first year?
That's not necessarily how it works.
Okay.
But this.
So I got 0.93 for like the 3 years in between.
Yeah. So you could use that.
And then divide it by 3.
Yeah. So that would give you for 1 year.
And that gives you 0.31.
Yeah.
So it'd be 0.31 t.
Yeah.
And then plus something. That's equal to h.
Well done. We need that something.
So could we make it to like, could we make it equal to 2.35?
Yeah.
And then sub in 3 for t.
Very good.
And you get 0.93 again. You divide by 0.93 and for the left. And you get 2.53 to 3 sig fig for c.
And so find an equation linking h with t.
H equals 0.31 t plus 2.53.
That's great. B.
So could we just work it out by putting 140 in for the height?
Yep.
And then work out t.
When it was planted.
So that's 0, t is 0.
So t is 0.
And then c is 2.53.
So
you get 140 equals.
Forget 140.
Okay.
T is
so you
0.
get just h is equal to 2.53.
Yeah. What is that? That's meters. So that's like 253 centimeters. They said the height of a tree when it was planted was 140 centimeters. Explain whether or not.
Because the minimum it can be is 253.
Yeah. So 253 is not equal to, it's not even close to 140.
Yeah.
Therefore,
that the height of the tree cannot be 240 centimeters. Oh, this fact does not support the use of linear model.
Yeah. So we're thinking that the height of a tree, linear, straight line, y equals mx plus c.
Yeah.
They're calling y h and xt, so it's h equals mt plus c. And they're thinking maybe this is how trees grow. You know, by the same, they might have some kind of starting height, but then they grow by the same amount every year.
Yeah.
But actually, what they found was like, no, that totally isn't borne out, so it's probably not a straight line thing.
Yeah.
I just want to see. So that's like 3, 2.35, and 6, 3.28, and so t is that? So 3. 3m plus c is 2.35. 6m plus c is 3.28. I just want to see if we got that plus c correct, because it was 3 sig fig and they didn't mention anything about 3 sig fig. I'm gonna be disappointed with them. So that was 0.31, and that was 1.42. Where did you get this? So that's 0.31.
Yeah.
2.35 divided by 0. It's not divided by, it's minus, isn't it? Because it's not.
Oh, because it's plus c, isn't it?
Yeah, so we'd have to minus it. That's why. That is why. That's what was bothering me there. So c is like 2.35 minus 0.93.
Yeah.
And it's 1.42. And so does that support linear model for part B?
It doesn't.
Why not?
Because it's still c is. Oh wait, no. No, it does, because c is 142.
So 142 is very close to 140.
Yeah, it's just on 140.
Yeah. Therefore, it supports a linear model.
Yeah.
Great. Okay. Yeah, so that is, so maybe you just fully simplify, like 0.31 times 3. So just write down like 0.93. Just simplify as you go. That's kind of difficult to know with this kind of digital thing. There's trade-offs. We get through a lot, but sometimes. All right. How about this?
Okay. So, so first we're just doing differentiation.
Mm-hmm.
So you multiply, which gives you 6 to x. And then 24x can be converted to 24x to the minus 1.
Mm-hmm.
And then you get minus 24x to the minus 2. And they want it in the simplest form.
Mm-hmm.
So you'd make minus 24x to the minus 2 minus 24 over x squared.
Great. B.
So first we need to work out x.
Well, we need some kind of relationship. What do you know about a curve that's increasing?
It'll never.
Its gradient must be positive.
Okay. So it has to be greater than 0.
What has to be greater than 0?
X has to be greater than 0.
No. Gradient?
M has to be greater than 0.
And how do we use that?
Use y equals mx plus c, but it's not a straight line.
So how do you find gradient of a curve?
Differentiation.
Yep. dy dx has to be greater than 0.
Yeah.
What is dy dx?
What? 6x minus 24 over x squared.
And so that's the relationship that we're solving. So it could have been something's equal to something. In this case, they said range of values, so I was expecting an inequality. Right, how are we doing this thing?
Would we want to convert x squared back to minus 24x to the minus 2?
That's not. They made us do this. I'm sure it's for a reason. How can we solve this thing?
Could we divide by 6 on both sides?
All right. What do you get?
X minus 24 over x squared is still greater than 0.
Don't do that. Don't do that.
Okay.
So the big problem here is the fraction.
Yeah. So can we just multiply by x squared then?
So that's a lot better than dividing by 6. All right. What do you get?
It's still greater than 0.
Yeah. And on the left side?
Well, it gets turned into 6x cubed. And that's minus 24.
And now, if you really want to, you can divide by 6.
So you divide everything by 6 and you get minus 4.
Yeah. The last time you didn't... You said minus 24 over x squared, but it should have been minus 4 over x squared.
Okay.
Right.
And then you could plus 4 both sides and then cube root.
And so what's the answer? You don't need the calculator.
Cube root 4.
Yeah, so x is greater than the cube root of 4. That's an exact value. That's great. Let me think about this. Find the exact range of values for which it's increasing. Yeah, like when x is greater than the cube root of 4, this curve is increasing. Yeah, if it's increasing dy dx, like the gradient has to be like positive. So the gradient has to be greater than 0. And this is a curve, and so to find gradient, use dy dx. What if we had to do range of values of x for which the curve is decreasing?
It has to be lesser than 0.
Yeah, and so the final answer for that one would be x is less than the cube root of 4.
Yeah.
I hope. Just doing that off the top of my head. Let's see this one. Unless you have any questions about that previous one.
No.
Moving on. Right, how's about this?
So for this, we'd need to use half times AB times sine, right? Sine C.
Yeah.
So we do a half times 3x times 2x times sine 60.
Mm-hmm.
Oh no, yeah, that's equal to 18 root 3.
Right.
Then you can divide by a half on both sides.
If you insist.
Okay. And then you can divide by 2.
If you insist.
And then divide by 3. And then you can do sine 60 and
Yep.
divide by that.
Yep.
And you get root 3 over 2, and then you divide by that. So. And now you only have x times x on both sides, and then equals 12, and then you can just x squared is equal to 12, then you square root x, so it's square root 12.
Yeah.
But no, it says, but that's, wait, I need to simplify it, or is that wrong? Oh no, it's right, it simplifies down to, yeah.
Yeah, so you just need to do that final step.
Yeah.
Alright, B.
Okay. So now we just sub in 2 root 3 for x.
Yep.
Then you get 6 root 3 for 3x.
And 4 root 3 for the other.
Yep.
Right, we want the exact length of BC.
We can use cosine rule.
Sure can.
It's c squared equals a squared plus b squared times
Minus.
minus 2ab times cos c.
You confident with that?
Yeah.
Yeah, you'd be grand. Yeah, you made meatballs out of that one. That was easy peasy. Yeah, I suppose it's kind of, an extension of GCSE, cosine rule, sine rule stuff, area stuff. Hang on a sec. Read. Okay, how about this one?
Okay. So is this like, okay, is this like them graphs that go like top right, top left, bottom right, bottom left?
Yep. So which one is this?
Is it bottom right?
No, that's negative.
It has to be in the top then.
Go on.
So top left.
No. Let's see. What if it was... So k is a constant.
Yeah.
What if it was 1 over x? But do you have graphical calculator?
It's downstairs.
Downstairs you in a minute. Y equals 1 over x. So let's say they have k as some rando number. Let's say
Yeah.
graph. I'd delete this stuff. Delete that. Some good maths was in there. Okay, y equals, I'm going to say k is 7. So y equals 7 squared. You can pick any random number over x. Shift zoom auto maybe? Yeah. Okay, that's what it looks like.
Yeah.
You get the idea. So 1 over x, anything over x, any number over x is going to look something like that.
Yeah.
However, we have a plus 1.
So it moves up the x-axis
How many spaces?
by 1.
Yeah. Okay. And so you have to say the equation of the horizontal asymptote. What's that about?
So the equation of the horizontal asymptote will move the graph by 1.
Horizontal means going across. Asymptote is the line to get close to but never touch. You have to find the equation of this black line.
Y equals x plus 1.
Y equals 0x plus 1, or just
Okay.
y equals 1. Yep. That's it. That's a key stage 3 thing. Everyone forgets it though.
Yeah.
Alright, how about B?
Okay. So for B, there's no way to sub in y for the equation
Why is that?
because it wants the x coordinate.
They're both equal to y. You can definitely make them equal to each other if they're both equal to the same thing.
Wait, is it top and bottom? Is it top? Is it like the? Are we using the equations as top and bottom?
Yeah, that's C, the curve C, and they just gave us the line L. So L with C.
Okay. So we could just make it minus 2x plus 5 is equal to k squared over x plus 1.
Yeah.
And then we can just do minus 5 on both sides.
You love minus and stuff. Always get rid of these fractions first.
So multiply by x on
Yeah.
both sides. So you get minus 2x squared plus 5 equals k squared plus 1.
If they have plus or minus in between, you have to times them all by x. It's times everything by x.
So you get minus 2x squared plus 5x equals k squared plus x.
Yeah. So it's kind of like if you were to put a bracket around it and just say like left side times x, put a bracket around that, right side times x. So it's like you expand the bracket, so it's times everything. All right, nexty.
Okay. And then we can minus x on both sides.
Let's see. So they have a positive k squared. That's a
Yeah.
positive k squared. So we'll move everything to the right.
Minus 5x on both sides.
Yeah.
And you get minus 4x.
Yeah.
And then you can plus 2x squared on both sides.
Yeah. And just make sure, silly as it seems, the very last thing you do is just write exactly what they have.
Yeah.
How about B?
Okay.
Sorry, C.
So if we want to work out k, well, we don't know what x or k are both are, so we can't really. There's a tangent, does that mean?
So back, they were saying like it's equal to 5 or something. It would have looked like that.
Yeah.
So it's got that what it looked like. However, if it's a tangent, it's kind of like just like that.
Yeah.
What is that? How do you use that information?
So at one point on that, it would be the same as the gradient would be the same.
This one's got 2 points of intersection. This one's like it's a tangent. It's only got 1. Therefore, one real root only.
This is equal to 0.
What's equal to 0?
B squared minus 4ac.
Boom.
So we have B, which is minus 4. And then A is 2, and then C is 1.
Solvey solve.
So it'd be 16 minus 8 equals 0.
Wait. Where's K
I'm
gone?
working out k.
Where's K gone?
It'd just be k squared for 1.
K squared is C. Because K is a
Yeah.
number. Yeah. So 16 minus 8K squared equals 0.
You can simplify it to 8. K squared equals 0.
What do you do, sorry?
If you do 16 minus 8, it would give you 8, so it'd be 8k squared equals 0.
That's all kinds of... I don't know how late you're staying up at night saying something like that. How about 16 minus 8x squared equals 0?
Oh. Okay. So do you want to minus 16 on both sides and multiply by minus 1?
Yep. So 8k
Get 8 squared.
squared.
And then you can just divide by 8.
Yep.
And that gives you 2, and then it answers root 2.
Why do they say values?
Plus or minus root 2.
Yeah. K equals plus or minus root 2.
Yeah.
So things got messy there, but let's see. So the big thing is, yeah, this one up here, b squared minus 4ac would be greater than 0 for 2 real roots, but tangent b squared minus 4ac is equal to 0 because it's one repeated root. Let's see. If you have to find out where two graphs cross over, or a line meets a curve, all that, make them equal to each other.
Yeah.
Because where they cross over, they are equal. This shape, like this graph, y equals 1 over x, that reciprocal graph, that's the positive one. Top right, bottom left. Just like positive cubic. Top right, bottom left. Negative one would be the other two. Just like negative cubic. Plus 1 moved to up. This weird thing, horizontal asymptote, that's this line across. So it now moved up by 1, so it's y equals 1.
Yeah.
Other than that, It's all right. Yeah, graphical calculator. Rock and roll. Okay. Yep. How about this?
So for this, would you need to do like 10? No, 0, choose 6.
6 choose 0.
6 choose 0, then it's like 6 choose 1, 6 choose 2. And then you have the another bracket, which would be 2.
Mm-hmm.
And that's just going up in squared by 0, 1, 2.
I believe other way around. If this was like, if you have a bracket like x plus 7 squared, it kind of starts with the highest one.
Yeah.
So the x kind of goes down. So that starts with the highest one.
Mm-hmm.
So, what are they? What are the powers?
6.
Yeah.
7.
That's
5,
it.
sorry.
Go on.
And then 3x over 4.
Alright.
And that's to the power of... Does it go from 0 to 6?
Yep.
So 0, 1, 2.
By the power of Grayskull. Alright, how do we do this?
And just calculate it.
Alright. How do you deal with the x?
You just put that in for 1.
Yeah. Alright. Let's use the first 2. You'll probably beat me to it.
I got 64 for the first one.
Alright. I got 135.
And then for the second one, I got 144.
144. So, what do we do about these x's?
You put them back in.
Yep. What's the answer?
So like 64 stays the same, 144x and then 135x squared.
Yeah. Wait. Yes, because the second term has the x, so the x is going up.
Yep.
B.
Okay. You just do wait. So can you just do like 1.925 choose
No.
6?
Spot the difference.
whole bracket's just 1.925.
Yep. 2 plus 3x over 4 equals 1.925.
And then you can just work out what x is from that.
Do it.
So you could multiply everything by 4.
Now you're talking.
So it becomes 8 plus 3x equals 7.7. And then you can minus 8, which gives you minus 0.3. And divide by 3. And you get minus 0.1.
Right. Let me see. Use your expansion to estimate that value. How do we use our expansion?
We sub in x 0 for like x in the equation is for minus 0.1.
Yeah, so what's the working out that you show? What do you type in? What do you type into your calculator?
So if you want it to be to the 6, do we do like...
Don't worry about that. X
Okay.
is minus 0.1. Use your expansion.
64 times 0 minus 0.1, and then 144 times minus 0.1 squared. Oh, 0.1, sorry, because it's not squared. The next one's squared.
Yeah.
So,
Let's see. Squared. Right. So quick way is just minus 0.1. Then we use answer 64. Hold on. Did that work? Answer. Yep. Sorry, I said a tenth. 64 plus 144 answer plus 135 answer squared. 50.95. And let's just put in the wrong way of doing it, which is to get the exact thing. 1.925 to the power 6. And we get something close to 50.95. There we go. 50 point. Yeah. Right. So this one, I knew you'd be fine with part A, but we need it for part B. This is the most common question in the world. Something to the power of x, something to the power 6, something to the power 6. So part B, they'll say use your expansion to approximate some value. These two must be equal to each other. X is minus 0.1, and you're going to get an answer like that. 0.1, 0.01, something like that.
Yeah.
And then sub that into your expansion, and you will get something close to that. If you just put in 1.925 to the power of 6 in your calculator, 0 marks.
Yeah.
That's an exact value. You didn't approximate nothing, you didn't show nothing.
Mm-hmm.
Right, let's see. How do we do? Part A, you're pretty good. Just don't lose. With part A, when you had like two A terms, and you say, well, we divide everything by A, the problem is you would lose the A equals 0 solution.
Yeah.
So instead of dividing by the unknown, you factorize.
Yeah.
How do we go about part B, solving a quartic?
We had to make b squared be equal to u.
Yes. So then it goes from being a quartic to a quadratic. You solve that, and then you swap it back. And so u is 2, and so b squared equals 2. Never forget the plus or minus. B squared is 2, and so b is plus or minus root 2.
Yeah.
Let's see. These ones, that looked all right. How do you subtract a bracket?
You need to multiply by minus 1 to
Yeah.
get rid of the minus.
Yeah, and it's very, very common to have to do that for a integration question, because it's, first one minus second one. Let's see. Why do I have these blanks? This one, I mean, you got it. it's basically y equals mx plus c, h equals whatever it was, mt plus c.
Yeah.
Just be careful with them. Just simplify as you go. You're good.
Yeah.
Let's see. That was the same thing. I did it by simultaneous too. Any way you want.
Yeah.
Let's see. 3x squared. X to the minus. That was the minus. What do you know about if a curve is increasing?
Then the gradient has to be positive.
Yes, and they're never going to ask you for the gradient of a straight line. They're
Yeah.
gonna ask for dy dx. You know.
Yeah.
That was good. This one. Let's see. There's a lot. Just learn your reciprocal graph.
Mhm.
It's the same as a cubic, same corners. Plus one moved it up. Horizontal asymptote is this like line it gets close to but never touches.
Yeah.
The vertical asymptote in this case would be going the other way, like x equals 0.
Yeah.
The y-axis basically. Where do they cross over? Make them equal to each other and solve. And if it's a tangent, discriminant is 0. Part A is fine. It's only part B. This equals this. Solve for x and sub it into your expansion. That's gonna be on your test. Always is. What do you give yourself there?
Probably between 2.5.
It's not bad. And so your thing is on Tuesday, is it?
Yeah.
So anything in particular you want for next time?
No.
All right. Any questions in general?
No.
All right. Well done, Adam. Have a good weekend.
You too.
I'll talk to you next time.
You too. See you later.
All right. Take care. Bye bye.
Bye.